allowing me to explore that. It was really extraordinary. I really hope to return to the zoo here because it was just an incredible set of things. I did see the kookaburra too, although I confess I couldn't recognize whether it was in a gum tree. Okay, so I would love to show you many things, but let's focus in on just a few. So one of them that has recurrently come up is this issue of performance, model performance, and I wanted to see if I can briefly cover a few words on the model performance side within AnyLogic. Agent-based models impose large computational burden. And there's several reasons for that. One is they have many moving parts. There's a lot going on there, many agents, a lot of things to calculate. Another one is there's this requirement, which we'll get to shortly, of running multiple realizations. By that, I mean typically to develop confidence in the results of the model, you're forced to grapple with the fact that these models are stochastic. So on a run-by-run basis with the same parameter settings, the model will generate different results. And for that reason, to assure that we're not simply fooled by the vagaries of chance, by a fluke that suggests one intervention is better than another, but to instead help us ground firmly our beliefs and convictions in much evidence, we're typically running these models many times over. And we'll see that AnyLogic makes this very easy in a little bit, but for that reason it tends to be expensive. Now, this computational burden does have a cost. There's an opportunity cost. It reduces time spent in exploration of models, and it can lead to less limited exploration, or more limited exploration of parameter space. Now, I wanted to talk, therefore, to talk about this issue as a first-order issue, not to brush it under the rug. And I wanted to highlight particularly a few areas where I think performance considerations are brought to the fore. I think Dylan may have mentioned one or two others. Certainly, he did in some of his comments in the course of the workshop. One or two places where performance issues have arisen for you.
Not in the talk, but of course in informal conversation.
And could you remind, there were one or two cases you mentioned, I think.
Interpolation.
Mm-hmm.
So there are...
Right, interpolation.
Yeah, you can have a custom distribution, and if you use linear versus spline versus step, it makes a difference. And when you use system dynamics in an agent,
right,
and you're not careful about it, sometimes that can slow stuff down.
Right, so system dynamics calculations, you should be sure to check the step size that's used for those calculations. That makes a first order difference, and often AnyLogic sets that default step size to a very, to a conservative number, one that's quite small. But I find that many of my students' models do not require, in fact, that small a step size, so it can go much faster. Dylan also noted custom distributions, but I would note that the same issue of interpolation, say with splines, which involves more calculations, also applies for table functions. So those are some good comments. Here are some additional ones. One's having to do with time issues, which have bitten people in this boot camp, recent boot camps, recent student performances. Realizing there's event-limited performance issues, issues associated with population statistics, with visualization, and with network construction and output of data. The issue with time consistency, many of you has bitten many of you. While AnyLogic allows for specifying model and time units associated with model quantities, a default measuring stick, say days or seconds or years, AnyLogic's default time unit is extremely fine-grained, to wit, seconds. This would not itself be of tremendous import, except for the fact that that default, whatever it is, sets the default time unit that's used for specifying quantities. So, for example, if you say a timeout and you say 1, it will, if the time unit of your model is seconds, it will be by default 1 second. If you have a rate of 1, it will be by default 1 per second. Even more notably, if you have a chart, the default automatic update time for that chart will be what? Every second. So a common scenario to which I've seen many students fall prey is you create a model and you pass quickly over this issue of creating the model and you don't notice this issue of seconds. And then you start adding model components. Maybe you add some charts, you add some transitions. And then you realize, oh, wait a minute, this is crazy. It's seconds. So you go and you change AnyLogic's time, default time unit to be years. And that's great. And you've taken a big step there, that's good. But you're not out of the woods yet. Because chances are, unless you were careful about it, your charts are being updated once per second. Certain transitions are being updated once per second. And this can lead to extremely slow behavior. Some of you have seen it. It seems like nothing's going on in your model. Things are going on. They're just going on every second, and your interest is at the level of years. So it seems like nothing is happening. As a result, I would urge you to get into the habit of either in that opening wizard, as it's called, when you can say to go to create a window, or, a new model, or as soon as the whole model files is open, you finish creating, that main class, the default components there, you go and you change the time units immediately before you start adding components. If you do make this mistake, as we will inevitably from time to time, just be sure to look through charts as well as state charts, as well as events, because all of those could be contingent on this and could lead to tremendous slowdowns. For example, an event that you think is set to go off every month is in fact going off every second. That can be really problematic because in a year, there's over 3 million seconds. And so that chart may have to be updated 3 million times before you can make a progress of a year. Okay? So be careful about that issue. It strikes many people quite often, and it can be frustrating, but boils down to something very silly. Okay. Another thing to be aware of is that AnyLogic beneath the surface uses what's called a scheduler, which runs to handle events from the model. And events come in a variety of different contexts. It's not just the event object, although that's an important source of events, but it's also things like state chart transitions. It can be events associated with updating outputs, like charts. It can be events associated with things like sending messages. And AnyLogic has a lot of what dictates how quickly it runs in maximum speed mode is how many events are being processed. So, some models that I've debugged for researchers who have kind of said, can you help me debug my model? Why is it so slow? Within just a few minutes, I found it was just an event going off gratuitously quickly. For example, it was checking the status of a sexual transmission network every 2 minutes or something like that, which was completely out of range of what was needed. In this context, being cautious about how many events you trigger, and if you have a choice, being judicious about it is good. There are also some tricks which can be useful, and sometimes we're trading off the number of events you send and the likelihood that those events will make a difference. For example, the likelihood of infection given an event that you might want to think about. There's some additional components as well. There's two ways to send messages in AnyLogic. One is asynchronous, and it's called send. Another is synchronous and called deliver. By synchronous, I mean that it leads immediately to it have to be processed. Synchronous, it is handled by the other agent at some potentially later, at some later chronological time, but in terms of the model, the same logical time. So this is faster, but you can't get infinite loops with deliver because A can call B and B can call A, and you have to watch out there. But just be aware that this can have some performance implications. And generally, if you have greater occurrence of events, it will adversely affect performance. Those of you working with that very first model on which you tried things, that model of that where we just added that transition, do you remember that? Long time ago? That model got very, very slow in terms of its apparent progress when there were lots of people infected. Why do you think that would be? Well, lots of messages are being sent, lots of events are being scheduled, and as a result, it has more work to do. A few suggestions here. Lower the event frequency. We'll come to this disabling of visual elements. Lower the event frequency. You can use dynamic events rather than having regular events that are sometimes ignored. You can schedule a dynamic event on a per needed basis to go off exactly an amount of time from now. We didn't have time to cover that. You'll find lectures by me on it online. You can, in some cases, and this will relate to a later thing, actually use variables to keep track of things rather than depending on population statistics, and a profiler to find where it's spending time. I noted this notion of sending events only for an infecting dose rather than for exposure. Now, I wanted to highlight this one about the profiler, okay, because there was some interest in it expressed. I'd like to take this model that we've built, and I'm going to go examine it for a case where we have no stop time. So you'll notice it's stop time never, rather than a fixed stop time. And I'm going to run this with a large population. Okay? People okay with that? So what I'll do is